and I'll introduce Chloe Brimicombe. And Chloe is a postdoc in working on the High Horizons, which is an EU Horizons project that explores the impact of heat on maternal, infant, child, and health worker health. She works at the Wegener Center at the University of Graz in Austria, and before that, she was working on a PhD at the University of Reading with ECMWF, and her PhD is entitled Too Hot to Handle. So you're guessing where we're going with the talk here. She was awarded the Malcolm Walker Award, which is a Royal Met Society Awards in 2022 for the outstanding work that she's done early on in her career, working on the heat early warning system and her role as a science communicator as well. So I'm delighted Chloe's here today, joining us from Austria. And her talk, as you will not be surprised, is on heat waves.
Yeah, thank you. Hopefully I will do a good job after Ian's really good summary. So I'll just share my screen now. So yes, I will go into a little bit more detail than Ian perhaps, and we'll be focusing on UK heat waves and also heat stress. So just in case people on the call weren't aware what heat waves are. So there's a guideline definition by the World Meteorological Organization, and heat waves are a period of 3 or more days of above average temperatures in regions warm season. Here in the UK, the Met Office definition is 3 or more days, and there's special thresholds for each region of the UK. And the season runs between the 1st of June and the 15th of September. And actually, if you look at historical records, that still fits pretty well, even with climate change for the moment, but that season could shift. So also what Ian was talking about, so the reason that we saw so intense temperatures over parts of Europe, the UK, but also sort of in parts of America is because of the drought. And we have Stephen talking on behalf of CH, I think, after this on the drought. So basically what happens is when you have dry soils, you have more of a sensible heat flux than a latent heat flux. And basically this means that the temperature is raised higher because of that release of energy and that energy transfer between the soil and also the atmosphere. And this was very important, as Ian was saying, in the drivers of our really intense temperatures across the UK and also Europe in the summer this year. So as we were saying previously, like the record-breaking temperatures were widespread across the UK, which you hadn't really seen before, and 46 stations actually apparently exceeded the previous record, which was from the 25th of July 2019, where we also saw like quite dry conditions across wide parts of Europe and also these high temperatures. And then, as Ian was saying, we had that record broken on the 19th of July in Lincolnshire. I was in the University of Reading actually on the 19th of July, and we were trying to run a mathematical ecology conference, and it was actually just really quite horrible because we had to like make sure the ventilation was all good, but it was like stiflingly hot. And I remember going outside like not during the middle of the day, but like before the peak of the day, and it was like akin to being in a desert in the middle of Reading, which was very strange because that isn't something you usually experience in the UK. And the wind was like very warm, which was incredibly strange to me. I think it's probably a memorable experience for everybody. Probably maybe even will hopefully replace 1976 in people's minds. And then, as we were saying, the minimum temperature was also very high with tropical nights across the UK. And yeah, this was just very, very high temperatures, definitely unprecedented. So in terms of heat stress, is how we feel either as a result of exertion, so exercise and or our external environment. And this can take into account factors like temperature, also like relative humidity, so how much moisture is in the air, and then also wind speed. So these are 3 different ways we can account for heat stress. And what you can see is there was strong to very strong heat stress during the period of this heat wave in the UK, but you can also see this across large parts of Europe. As Ian was saying, this was very much a European scale event, which wasn't really the case if you look at the synoptics of 1976. And so this was very much different to that, and also had higher temperatures than that, and higher impacts. So if we look at the impacts, we had 2,227 excess deaths in the period, and this was in the heat health period. So a heat health period is different to a heat wave. It has different thresholds, and it's just a way for the UK Health Security Agency, formerly Public Health England, to issue alerts to vulnerable people to heat, so over 65s, pre-existing medical conditions, pregnant women, and those under 5, and people that care for them, so that they can put in place cooling measures and give them messages like stay hydrated, like targetedly. But we still saw the highest excess deaths, and this is the highest excess deaths for the summer, actually, since the heat health plan was put into effect in 2004 after the 2003 heat wave. But it's important to note that heat waves don't just cause these mortality impacts, they also have lots of other impacts. So there was a no travel warning in place, national emergency across the red part of this extreme heat warning. And the extreme heat warnings only came into effect in 2021 for the UK. And this was the first red extreme heat warning. And it was the same level as the storm we've seen earlier in the year. So the same sort of threat level to life. And so there was no travel warnings. There was lots of signal failures, lots of wires sagging. And then what was interesting is that Google had to shut its UK-based data center. Data centers are set in places where they think are like least vulnerable to risks, and they didn't put in place enough cooling capacity in the UK for them to be able to keep that data center running. And then also what was really interesting across the summer, so in this heat wave and also in August, was the compounding wildfires. So there was lots and lots of wildfires all across the UK as a result of the drought and the heat. And for this specific heat wave, they said that the fire service said that this was their busiest period since World War II. So then if we move on to look at the August 2022 heat wave, so the pressure pattern was slightly different to the July heat wave, which caused it to be able to be prolonged for longer. And actually the heat health warning went on for about like 10 days, whereas the period of the heat wave was about 5 or 6 days. So there was these are some charts that show sort of the maximum temperatures from a GFS run valid for the 13th of August from the 10th of August. These were the sort of charts that you would see in the media from this heat wave. And then also the pressure pattern chart. So yeah, this one was more prolonged than the previous one, and that was because it was a slightly different pressure pattern, allowing it to be prolonged for longer. So then the heat wave. So what we were saying is that, so over the period of this heat wave, it was longer, and therefore the excess deaths over the period of the 10 days was more than the July heat wave. However, for the July heat wave, you saw more deaths in the peak for that day than you did over the 10 days of the August heat wave. The reason that there was more deaths over the August heat wave was because, as Ian and Liz were saying, your body had less opportunity to cool down because it was higher temperatures for longer, and therefore you see a rise in heat conditions. But the peak, because it was so intense, that caught a lot of people out, and so you saw quite a lot of people suddenly losing their lives or being hospitalized because of how intense that spike was. I think the August heat wave is more sort of notable because of the compound effect it had. So there was, over the summer, 4 times as many wildfires in the UK in 2022 as there was in 2021. And 2021 was it. There was a couple of notable heat waves, but definitely 2022 outranks it quite a lot. And so we suddenly had this need to have the communication of a drought where you need to save water, but heat wave where you need to drink more water, with wildfires where you need the water to put the wildfires out. So it was a very complicated event. And I think if you look at pictures from the time from the media, you can definitely see that. This was not a red heat warning, it was just an amber, but still very significant, especially given that we just started doing these heat warnings last year. I don't think it's something we kind of expected. And then looking forward, basically what we know is that if we reduce emissions, we reduce the likelihood of heat waves, and we reduce the sort of intensity of them getting any worse. But even if we look at a net zero scenario, which is an RCP sort of 2.6, we know that sort of we would likely to see like 40 degrees Celsius or like heat waves like 2003 regularly by sort of mid-century. And currently, without heat adaptations, by end of century, we could see 5,000 people losing their lives in the UK as a result of heat waves. And so this is why it's really important not only to mitigate so they don't become any more intense and we reduce their likelihood, but also we need this adaptation. So we need cooling centers, natural ventilation, urban greening, all of those sort of things, as well as the mitigation strategies, because, you know, I think we should have mitigated faster and harder in the past, because now we're kind of in a situation where we both have to mitigate and adapt to climate change. So if you have any questions, I would be really interested. And also all of the pictures from like the August and this end slide, I chose from actual media articles that appeared during the August 2022 heat wave. There was a wide range, and so hopefully that was interesting. Thank you so much.
Brilliant. Thanks, Chloe. Really interesting and good to focus on heat. I think the one thing you drew out from your presentation that we didn't pick up in the first talk is the importance of humidity when we talk about heat health as well, not just the high temperatures in the daytime and nighttime. And there was a comment from Norman at the end of Ian's presentation about tropical nights, and he recalls working in Bahrain, woke up and he thought what was the sound of rain falling outside, but actually it was thick fog because the dew point was 32 degrees Celsius. So, you know, really high humidity, and that obviously puts greater stress on the body. So great. Okay, so I think near the beginning of your talk you mentioned the boundary layer, and I guess probably the importance of the boundary layer when we're looking at heat waves. So Dominic just asked, could you explain, I guess, the role of the boundary layer and why it's important when we think about heat waves?
So I don't specifically focus on the boundary layer. From what I know is it's important because of how high the boundary layer is. So during a heat wave, as far as I know, the boundary layer helps to trap in the heat, and that's what causes that sensible heat flux. Basically similar, how I describe it, similar to an oven. So you have that dry soil, and then you have the rise in the sensible heat flux more so than the latent heat flux, which is the condensation. And basically that helps to trap the heat in, and the boundary layer comes down and just basically helps to create that oven effect, or maybe a heat dome effect. So that is kind of why it's important. And you also, as Ian was saying, you see that more so in urban areas than you do so in the surroundings. So it is a very important factor, and I know people at the University of Reading look into that more than I did. So
brilliant, thank you. So on the last slide, when we were looking at future projections, you mentioned RCP 6.0. So someone was just saying, what is that? Could you just say a little bit about, I guess, RCPs in general?
Yeah, so RCPs are different emission scenarios. So it's sort of a way of looking at how much emissions we would produce. So at the moment, I think we're on around an RCP 4.5, which is, I can't specifically remember, it's something to do with the energy released when you produce the emissions. So a 6 is between sort of an 8.5, which is the most catastrophic emission scenario you could think of, very unrealistic. But then also, like, if we don't see countries hitting what's called like their national contributions to the Paris Agreement, which is the agreement to limit warming to 1.5 degrees Celsius. If they don't hit that and then they just slightly increase it, we could see RCP 6, which would mean that I think on the slide I showed it was like between 4 and 6 degrees Celsius above average maximum temperatures in UK summers. So it's very important to reduce those emissions down as far as we can, because it reduces the maximum temperature increase, basically.
Great, thank you. And obviously, we looked at the heat warnings that the Met Office were issuing during 2022, the first time we've seen a red heat warning. But also we've got the heat health alerts. So there are kind of two things going on here. Do you just want to say a little bit about, I guess, the difference between them?
Yeah, so there's currently 3 different warning systems in place for the UK Met Office. I think I've seen a report saying that they're hopefully going to change it to 1 this coming year, which would be awesome. Because at the moment you have the heat health warning, which is UK Health Security Agency, has different thresholds for different regions. So, for example, when we saw the red heat warning, we'd had yellow heat health warning, amber, then red for a longer period before the July heat wave. And that's the period they do the mortality over as well, because that's sort of in kin with heat stress. So like how raised likelihood of people that are vulnerable to heat experiencing heat illness. And then we have the heat wave, which is period of 3 or more days above a certain threshold. And then we have the heat warning, which is again a slightly different threshold to a heat wave and a heat health warning. And that indicates sort of risk to infrastructure and also human health again, but not in the target group, outside in the general population as well, which is really confusing.
Yeah, and I was going to say, when you communicate about heat waves, particularly to a UK audience, because the threshold's different where different parts of the country, so it becomes quite challenging, doesn't it, to try and give a quite simplistic overview of what heat waves are when you've got all these different thresholds and different alerts and warnings taking place. So as you say, some sort of streamlining of that, I think, would be helpful for communication. So I was just going to say, has anyone's got any questions for Chloe? We've still got time for a few more questions, so please pop them in the Q&A. But I guess your final slide, when you asked for questions, had some images on, and as you say, you'd added some images throughout the slides, and actually found some really good images that show the impact of heat. And I guess my question is around the use of images to help tell that story, because the media, I would say, haven't been very good at that over the years. So whenever we have extreme heat event that causes an increase in mortality rates, we tend to see pictures of people enjoying the heat, so at the beach or having an ice cream, or kids playing in a fountain kind of thing. So actually having more images that help to tell the more negative side, I guess, of heat waves can be really useful to tell that story. So it's really useful you had those. I just wondered if you had a view on the use of images really to help get those messages across as well.
Yeah, definitely. I think I know that a lot of people in the field of heat waves have mentioned it as well. Like, it's very difficult to portray heat as a risk if you have pictures of people at the beach kind of enjoying themselves. Of course, if you should also be able to kind of enjoy yourself, but in a safe way, and that isn't what the images are portraying. And also in the August heat wave, it was very interesting because in the July one there was a complete change, and we did manage to get more of those risk images across in the media. But in the August one, you suddenly saw all these images of drought or wildfire, and then being communicated as heat. And I think it's very important, if we're going to adapt, that we we show that they are compound events happening together, but also they all portray a risk, and we need to adapt to their risks separately. And you know, they are all dangerous events, so we need to really portray that, I think.
Yeah. Do you envisage us in the future, or the Met Office maybe putting warnings out for things like tropical nights, which we've already talked about, and wildfires? So actually, we introduced the heat weather warning. Do you think we'll end up having different parameters like this that are becoming much more kind of high impact events associated with heat, but specifically for, as I say, the tropical nights and the wildfires, for example?
I think that would be really nice to see warnings for wildfires and tropical nights, and then also sort of the heat stress as well as the temperature. I also think it would be quite nice if, like, the Met Office in the future, you know, you could sign up if you were a pregnant woman or over 65 and get targeted alerts of what you should be doing to like limit your impacts. So like, you know, we could look into how much water should someone over 65 be drinking during a heat wave, and then send that out to people via like text alerts or via radio. So it would be really nice to sort of make it so everybody was kind of staying safe and had things that they could all do.
Yeah, no, absolutely. Great. Tabitha's just put something in the chat. It's more just a, useful point really, of the difference between the health alerts. They're in place to enable first responders and care providers to take action, whereas the Met Office is more for the general public. And I think that's quite a useful point, isn't it, to make?
Yeah, that's a really useful point to make. Thank you, Tabitha. Yeah.
But Norman has a question, I guess, a comment, but I guess it's about the importance of the difference between greenhouse gas emissions and the greenhouse gas concentrations in the atmosphere. And it's the concentrations in the atmosphere that I guess is the big important factor that's leading to global warming. So I don't know if you just want to say a few words. You know, if we can reduce emissions, but obviously we've got these concentrations in the atmosphere that will take a long time to start to reduce. So we may have to look at other factors as well to bring the concentrations down.
Yeah, I think a good first step is looking at transition to net zero, so that we don't, you know, have these greenhouse gas emissions. And also, you know, climate change isn't just due to greenhouse gas emissions, it's due to things like land use change and biodiversity loss. So there's other factors we need to look into. But you're right, like the concentrations in terms of also aerosols, you can have aerosols in an area, which means that the heat becomes more built up because of the absorption and reflection of radiation. So it is all things that we need to consider, and that's kind of why I think adaptation also is massively important, because we do have those concentrations there. We still have land use change. So it's important to consider all of these factors in terms of climate change, not just one aspect. So yeah, definitely important.
Great. And I think there's a really lovely analogy that I tend to use when we think about the difference between greenhouse gas emissions and concentrations, and that's that bathtub. So the tap of water falling into the bathtub are the emissions that we put into the atmosphere, and the body of water in the bath are the concentration. So even if we turn off that tap or turn down that tap, there's still water in the bath. It's the greenhouse gas concentrations that stay there and only slowly kind of reduce over time, you know, depending on kind of natural greenhouse sinks or sources, or technical kind of advances like carbon capture and storage. But that's a nice analogy, and I think Norman, it's a really good point, because we do focus on emissions a lot, and I think concentrations are a really important factor here. It's the thing that really matters. So great. Well, thank you, Chloe. Really appreciate that. It was a really interesting talk.